Thank you very much for waiting. Actually, my name is Hyde Sugiyama, Principal Domain Architect in Red Hat APAC. I'm now taking care of the several partners and customers to help their NAV business along with Red Hat OpenStack. My slide has been posted in the module site already. So you can get the same PDF file, which I'm going to use from the module site now. Okay, so today I got to talk about OpenStack version of Virtualization Infrastructure Manager in NFV system. NFV stands for the Network Function Virtualization. 3 years ago, ETSI, European Telecommunication Standard Institute, launched the industry-specific group for NFV, initiated by the 7 telecom carriers, British Telecom, FT Orange, Deutsche Telekom, Telefonica, Telecom Italy, AT&T, and Verizon. Since then, there are over 200 network operators, telecom equipment vendors, IT vendors, and technology partners are working together to define the requirement and architecture for the virtualization of network function and to address the technology challenge. Red Hat is also one of the participants. On this session, I'll be talking about NAV architecture to see how the Rail OSP should work. Also, I'm going to share the many information about NAV OpenStack POC leading by the telecom carriers relating to the NAV use case. You can see the technology challenge with Rail OSP, and perhaps maybe this information might be helpful for you to seek the new opportunity in the telecom partner and customers. Okay. Uh, Other than the open source community like OpenStack leading by Red Hat, there are several communities leading by the telecom vendors. OpenDaylight is driven by the many network vendors who focus on the SDN and network platform as a service. Cloudbound is leading by the Alcatel Lucent for the NAV ecosystem. OpenControl is also leading by the Juniper networks for the NAV ecosystem. All of them actually need OpenStack integration now. So we are at a good position to work with SDN and NAV players because Red Hat is at a network vendor neutral position. The vision of NAV is very simple. Telco vendors want to migrate from the hardware network appliance to virtual network appliance for reducing capex and to increase flexibility of network system designing and network infrastructure service deployment. There are many candidates which can migrate from the hardware appliance to the virtual appliance. DPI, firewall, carrier-grade NAT, and many other network applications are running on the Linux OS in most of the cases, so it is doable to run on the KVM hypervisor. By the way, can you see the slide? Okay, good. The idea of the NAV has been enhanced from the IaaS, Infrastructure as a Service. VNF, Virtual Network Function, means Virtual Network Appliance running on the KVM hypervisor. So VM instance and the VNF instance can be coexist in the same KVM hypervisor. A VNF self is a virtualization of a network function in a legacy non-virtualized network. Example of network function are the EPC mobile core network elements such as MME, turbine gateway, and PDN gateway. Elements in the home network such as SDB and DHCP server. Many network functions can be virtualized as a VNF. Its NFV provides a list of use cases and examples of the target network function for virtualization. I'll share the use case later. Functional behavior and the state of network functions are largely independent of whether the network function is virtualized or not. The functional behavior and the external operational interface of the physical network function and the virtual network function are accepted to be the same. OpenStack can manage virtualization resource including VNF instance as same as VM instance, but it is not doable to manage each VNF function. So other management elements are needed in the NAV architecture to manage each VNF function. This slide illustrates necessary components in the NAV. NFV implements network function as a software instance that run over NAV infrastructure. NAVI is totally of all hardware and software components which build up the environment in which VNFs are deployed, managed, and executed. On top of VNF instance, a network service can be built architecturally as a forwarding graph of network function interconnected by supporting network infrastructure through orchestrator for logical abstraction. In NFVI, the physical hardware resources include computing, storage, and network that provide processing, storage, and connectivity to VNFs through the virtualization layer. Computing hardware is assumed to be COTS. Computing and storage resources are commonly pooled. Network resources are comprised of switching functions. So there will be three domains to manage in NFVI: compute domain, hypervisor domain, and infrastructure network domain. In addition to OpenStack, which can manage virtualization resource, management element for virtual network function and orchestrator element for logical network abstraction are needed in the NAV architecture. Next, I will talk about its NAV activity to see how LSP works in the NAV architecture. Its NAV ISG set up the 4 working groups and 2 expert groups. INF working group focused on the virtualization and the infrastructure discussion. SWA working group focused on the software architecture discussion. RHEL working group focused on the reliability and availability discussion. MANO working group focused on management and orchestrator discussion. OpenStack is mainly related to the MANO working group, and KVM is mainly related to the INF working group. This slide illustrates its NAV reference architecture framework. The NAV architecture framework identifies the functional blocks and the main reference points. In MANO functional blocks, there are 3 components. Orchestrator is in charge of the orchestration and the management of NAVI and the software resource, and realizing network service on NAVI with OSS BSS. VNF Manager is responsible for VNF management. Virtualized Infrastructure Manager, VIM, is in charge of the control and manage the interaction of VNF instance with computing, storage, and the network resource. OpenStack can be the virtualized infrastructure manager. The NAV architecture is primarily concerned with describing the compute, hypervisor, and infrastructure network domain and their associated interface. Let me dive into the further detail for the NFVI and the VIM. TD compute domain and HD KVM hypervisor domain and the IND infrastructure network domain are controlled by the VIM. virtualization infrastructure manager in which OpenStack runs. The infrastructure network domain mediates a network resource to the virtual network container interface, which carrying the communication between VNFC instance. The hypervisor domain mediates the resource of the compute domain to the virtual machine of the software appliance. The hypervisor domain itself is a software environment which abstracts hardware and implement a service such as starting a VM and terminating the VM, acting on policy, scaling, live migration, and high availability. These services are not integrated without VIM. In VIM, two types of agents have to be run to communicate with open orchestrator and VNF manager in MANO functional blocks. If orchestrator uses Tosca, OpenStack heat component can be run as a Tosca proxy agent to the orchestrator so that the OpenStack heat component can orchestrate other OpenStack components. As for the VNF manager, currently many vendors are using specific API of each OpenStack component rather than heat component. At least three components oh, okay, have to be run in the OpenStack version of VIM. Nova component to manage hypervisor domain, Neutron Nova network to manipulate network resource in the infrastructure network domain, Thermometer to measure usage of compute domain, hypervisor domain, and the infrastructure network domain also need to run the Thermometer agent to measure the usage. Ironic project is also important to manipulate the compute domain. Okay. Uh, Actually, there are many discussions relating to each difference points. Uh, Most of the standard body basically focus on the such interface discussion without focus on the programmatic effort. But its NFV is focused on the programmatic effort, try to summarize the use case at first, then they are trying to do each POC to study each reference point. Okay, so next slide, I like to share that each POC activity uh, for relating the use case. Okay, each NFV focus on the NFV POC to find the technology challenge to each NFV use case. So I will share the status of each POC activity for each use case relating to OpenStack. But I think we don't have much time. I try to share the minimum use case at this stage. Uh, we have a we have 9 use cases in the HNAV relating their NAV business. So each network vendor are helping the network telecom provider to realize that functionality through the POC. NVI service provides a virtual network function such as the VCPE, VPE. Uh, I mean, NVIS provides a cloud application along with a VNF application in virtual network infrastructure. VNF as a service provides a virtual network functions such as VCPE, VPE, virtual firewall, and so on. Virtual network platform as a service, okay, provides many network instances such as OpenFlow, multi-slice, NVO3 and EVPN. VPN forwarding graphs are designed service chaining for network service to end user. Virtualization mobile core and IMS provides a virtual element for each function in EPC and IMS. And the virtualized mobile core base station provides a control plane virtualization to the radio access network. Virtualization of the home environment provides a virtual network element in home network. It is similar to virtual enterprise CPE such as the VNAT and vFirewall. And virtualization of CDN provides a content delivery virtual network, including virtual cache. And the fixed access network function virtualization provides a control plane and management plane virtualization for fixed network. Actually, six use cases are adapting OpenStack and KVM at POC. Red Hat actually are working with several POC members for the VPC and NAVIRs and VN forwarding graphs. I think we don't have much time to share the use case. Let me skip that use case regarding the okay. Maybe I can show the one use case what we are spending time. Okay. Regarding the use case number 5, VPC, we are working with Telefonica and Sprint to build a POC. Red Hat provides a virtualization infrastructure manager and KVM hypervisor to connect to perform the OpenVSH. And on top of the VIM, Xeon provides the orchestrator and the virtual VNF manager to manipulate the VPC application. So still this POC is ongoing, and Telefonica and Sprint are working with Red Hat to build this POC currently. Anyway, let me skip the use case since we don't have much time. And through the POC, its NFV player found several technology challenges in the OpenStack community. You know, the Red OSP had has a rich functionality and it's tied to the host OS. But to build a NAV system, Red OSP is not enough to build alone. So we need to work with NAV player to integrate VNF manager and orchestrator along with VIM. So we are trying to drive the NAV ecosystem with Red OSP together with several network vendor and telecom provider. And we are getting the feature requirement from the telecom provider and the telecom vendor who are spending time for the HNAV POC. And Red Hat it now launched the NAV subteam in OpenStack community. So through the OpenStack community, we are listening their requirement and discuss to discuss the best way to meet their requirement. So we need further work with the telecom provider and the telecom vendor and ISP partner and system integrator and the network integrator for the NAV integration business in the NAV ecosystem. There are many requirements for the Nova component. Actually, through the POC, they found the feature gap. So we are getting the requirement from the telecom vendor and the telecom provider to support to enhance the Nova components. Yeah. So we still are talking with many network provider and network vendor in the NAV subchain and OpenStack community. And also, there are many requirements from neutron component to manipulate the network. So through the POC, we understand that the key component in the OpenStack. This is a summary of the key component what the NFV player want to use. Meter they need to use to measure the usage of the resource and Nova component is a very important part to manipulate CPU resource and memory resource for the network application. And the neutron component is needed to interact with network functionality through the SNA plugin. In this area, we are working with many network vendor. So when we build an NAV system, we will have the we build a virtual infrastructure manager with OpenFlow controller solution and RHOS controller solution. And also we build the NVI as a computer node or OpenStack computer node and to integrate many NAV agent provided by the NAV players. So in this area, we are working with the network vendor, NAV players through the third-party certification program. Okay, and we because that we need further collaboration work with many network vendor and many network provider in the NAV ecosystem. Actually, in Japan, we are working with one of the major telecom vendor with providing the NAV domain architect accelerator service. Through this service, we are keeping the engineering engagement to discuss feature requirement, the feature gap between Red Hat and NAV player, and to find the best solution together. So we are trying to listen their requirement and to find the real issue. And we try to provide a good offer to resolve the issue through the regular technical advisory board meeting now. And I'm sorry for this time. We don't have much time to discuss because due to some trouble with the blue jeans. But what I wanted to share this time is there are many good NAV POCs adapting the OpenStack for good programmatic use case summarized by telecom vendor for their NAV business. So one of the good things for the NAV is that they are summarizing the use case relating their network business.
Sugiyama-san?
Yes. Yes.
You have 15 extra minutes after 12 o'clock, so please take those time.
Okay.
Yeah,
Sorry, I thought the 5 minutes.
No, don't worry. I just spoke with the next presenter. He can do his talk in 45 minutes. So you have 15 minutes extra. Is that okay?
Okay. Thank you very much. So maybe
You're welcome.
I can spend time for the Q&A. Okay. And okay. So the key point is that to build NAV architecture, OpenStack is a key component for the in the NAV MANO functionality block because OpenStack can be the virtualization infrastructure manager to manipulate the NAVI network NAV infrastructure. KVM is also is key component for the hypervisor domain in the NAVI. But there are other components still are needed to build NAVI architecture. So we have to work with the other vendor to build a network NAV architecture together. So uh, in order to integrate OpenStack, NAV players will need Red OSP enhancement to meet NAV spec. So they need to work with Red Hat through the OpenStack community. And we have many opportunity to communicate with the telecom vendor and the telecom provider to discuss NAV architecture with using Red OSP. So Red Hat is not the main NAV player, but it will be a key contributor. We can provide Red OSP because it's running on the KVM and OpenStack. So the important thing is we try to keep NAV vendor neutral and listen to voice from many NAV players to find the best way because there are many feature gaps. We need to communicate with a NAV player. And then we offer the good service which can help each NAV player to drive NAV business. Their goal is to try to make successful for the NAV business. As long as we can help them, they are happy to work with Red Hat. So one of the examples that we try to we can offer the NAV domain architect accelerator service, which can help NAV player to accelerate their NAV business. Okay. Sorry for we don't have much time. We didn't have much time, so I couldn't share the use case. But if you like to share, you like to see the several use case, I can share the slide. There are 9 use cases we have now. Uh, if you have if you have if you like to see that some use case, please let me know. I can explain that specific use case. Okay, maybe let me pick up the some slide because we are working with several partners. Other than the uh, other than VPC, we are also working with Telenor for the service chaining in the mobile network. This service chaining is based on the subscription-based service chaining that handled by the Telenor with NAV player. Then they are using that our Red OSP to implement OpenStack as a VIM and Red KVM as a NAVI. And another service chaining is actually performed by the NTT laboratory with using OpenFlow. They are also thinking about to use OpenStack, but they're still not ready. They are just using the VNF manager directly manipulate the KVM. But we still continue to work with NTT laboratory to implement OpenStack. So service chaining is one of the good business for in the telecom provider because they can design the end-to-end service through the service chaining with by manipulated by the OpenFlow or uh, OpenStack, Open VSH. Okay, I think uh, if you have a question, please let me know because that, uh, I think we have more 10 minutes. Yeah. Another important thing is we have to understand that what component they need, any player needs. At least they need a Nova component to manipulate their hypervisor domain, and also they need a neutron component to manipulate their infrastructure network domain. And as for the heat component, it's still most of provider are not ready to use heat as an orchestrator because still there are discussion in the Oasis who proposed Tosca. Uh, Tosca is it's orchestrator mechanism defined by the Oasis and proposed to the HNFV. It is that discussion is involved in the monofunctional block, and maybe the next phase they probably define that the orchestrator requirement. At this stage, most of the NAV player are using that specific component, that are specific API to the each OpenStack component from the VNF manager. And most of the NAV player are currently uh, developing the VNF manager along with orchestrator. But in the future, probably Open Orchestrator will be designed by the telecom provider instead of the network vendor, because orchestrator needs telecom specific functionality, telecom provider specific functionality. It's not easy to use standard product provided by vendor. So there might be several opportunities to customize, to enhance orchestrator with our middleware product like JBoss, which can communicate with OSS and BSS. But at that stage will be later, maybe the next year probably. So at this stage, we are focused on the VIM and NVI, so with providing the LED OSP. Okay, I think uh, I my talk, that is my presentation. Sorry for the uh, we didn't have much time to share the use cases, and but I already posted the presentation slide, and if you have any question, please contact me directly. Yeah.
Okay, thank you very much, Sugiyama-san.
Okay. Thank you very much for waiting, and yeah. Please reach me anytime if we are interested in NAV, and if you have any NAV opportunity, I can help you. Yeah. Thank you.